but I sat in an assembly committee once and they had an argument on what defines a hole and what defines a void in the solder for a couple of hours.
For a couple of hours, just the definitions.
Yeah.
Hello, everyone, and welcome to the Altium OnTrack podcast. I am your host, Zach Peterson, and today I'll be talking with Paige Fiet. She works at TTM Technologies. She was also the previous student liaison on the board of directors for IPC, and she's still heavily involved in IPC. Paige, thank you so much for joining us today.
Yeah, thanks for having me, Zach.
You know, I'm always excited to meet young people who get involved in the electronics industry. I can't believe I'm saying young people because I still consider myself a young person, but I just hit that next age bracket that you see on surveys. So I guess I have to refer to other people as young people. But it's always so great to see, the next generation getting involved in the industry. So maybe if you could tell us a little bit about your story and then how you got involved in the industry and how you got involved in manufacturing.
Sure. So right after my second year of college, I needed an internship. I was going to Michigan Tech for my electrical engineering degree, and I wanted some hands-on engineering experience. So I found a job in my hometown working on gas masks for the military, and they had a really small SMT line. I think they had 8 employees total. 2 ran the line, and then the others were doing through-hole assembly, and then they had 2 testers. So I worked with them. I learned all about SMT components. I created a bed of nails for them and just worked alongside them. The next year I was in college and I wanted to know how those circuit boards were built that I was assembling all summer. I thought it was the coolest thing ever. So I took an internship at Calumet Electronics in Michigan, and I somehow got into a class, a PCB manufacturing class at Michigan Tech that only had 18 open spots. And there I started learning about manufacturing, hearing from industry leaders like Happy Holden, and then started working in manufacturing at Calumet. Soon I fell in love with that. Totally. Like getting your hands dirty and working with the boards. And I was so amazed at how much went into making the little board that I'd been working with the summer previous.
So I know that one of the pain points for students, and I guess in the industry in general, is access to those educational courses a little bit earlier in the career path. And it sounds like you were able to access some of those resources while you were at university.
Yeah, the class was great. We had a lab and you had a lab partner. So you had 2 people working with a TA every class or every lab. And then the class was lecture based. So we would hear about what engineers both in manufacturing and assembly and design do day to day, what their jobs entail, and then learn about what they've learned over the past few years.
You know, when I was at university, I got to be honest, printed circuit boards was not anywhere in the curriculum at all. Maybe you got to use an Arduino in a class, but that was about it. That was your only exposure. And then my first exposure was when I was doing research. But the focus was so much on semiconductors, and semiconductor manufacturing. And I think that a lot of students get attracted to like the grand challenge, everyone says getting over the next hump of Moore's law. And so I think it's understandable that, some engineering students will gravitate in that direction. What made you go and jump into circuit boards instead of, some other area of electrical engineering? Is it just that they were, really cool and impressive to engineer?
Yeah, and a lot of my other labs, like my circuits 2 and circuits 3 classes, were just dealing with breadboards and through-hole components and circuit layout and design. And I wasn't amazing at it like some of my other students were. I enjoyed it, but I wasn't great at it. And then I found this circuit board manufacturing class and I just loved it. Getting to work with my hands and mix chemicals and make the different layers. I just thought it was so cool.
I definitely understand that feeling because I'm a pretty hands-on person myself, and I mean, when I was younger, I was working in a cabinet shop. So I always, like used tools and felt like you had to do stuff with your hands. So I get that. I think I get that attraction a bit more. But once you got into, into the industry, how did you become involved with IPC?
Yeah, so my professor from that class that I took, we became pretty close. I started TAing his class, working with Calumet, learning about the IPC standards that I hadn't really heard about in my other classes. And IPC's Education Foundation reached out and they were looking for a student liaison for the first time ever for the board of directors. And so my professor sent me an email and he said, I really want to nominate you for this position. And I was like, what? I don't think I would be good at that. Are you sure you want to nominate me? So I let him go ahead. I filled out this whole application on my end. We get sent home for COVID-19 2 weeks after I applied. And then I get a notification that I was in their top 7 nominations in the country. So I was like, well, that's great, but I don't think I'm going to get it. So from that point, they let all the student chapters across the nation decide who they wanted to be the new student liaison. And I got picked. I remember telling my parents, and they were like, that's so crazy. And then my first year was spending time on calls with the board of directors because we couldn't travel anywhere. We couldn't meet each other. We just spent 9-hour meetings over Zoom.
I know those meetings can be irritating, but I think it's important to have that opportunity to participate in those kinds of things. And my view is, I mean, I've sat on some standards committees, and my view is if you have something to give to the industry, then you should probably do it. But I think I'm wondering, like, what exactly was that like? What does the student liaison do with the board of directors? Is this to make sure that the concerns of like the student members are heard and understood by the board of directors as they make kind of broader decisions?
Yeah, essentially, it was all, what do the students want? How do we bring awareness to our colleges? How do we get this younger industry involved? And for me, just sitting on the board alone was like a projectile into the industry. I started attending meetings, I started meeting people, and you can really feel the love that these diehards have that have been in the industry for 40 years, And meeting those started to create this own love and passion inside of me.
Yeah, I've met quite a few people who are more experienced than myself. And so I totally understand what you mean about, kind of that infectious, love of electronics and especially manufacturing. And I've tried to make it my mission over the last, year or so to learn as much as I can about manufacturing. And, I think interfacing with those much more experienced people is a really important part of that.
Agreed. Wholeheartedly.
Yeah. And I mean, you get so much firsthand experience from them. Just like they'll tell you stories. They'll tell you some of the crazy things that they dealt with when they were, building boards. And you can just learn so much.
Agreed. I love hearing about the old technologies and how circuit boards started. They were there at the forefront of that.
Yeah, that's always fun. I think it's important to get the historical context for how we got to where we're at now. And then I think what's really great about the historical context is you learn about the engineering challenge that was confronted at the time.
Agreed. And you learn so much about what the original intent behind something was and then how it became what it is today. It's so crazy to me.
Yeah, totally agree. So if you go onto IPC's website, and I think specifically the Educational Foundation website, your picture is there. But I'm wondering, how does someone who is just getting into the industry and passionate about electronics, how do they get involved with something in IPC, and what can they get involved in?
Yeah, I always recommend going to the trade shows like Apex, I think is a huge one for IPC. They actually have an emerging engineer program that I'm in right now. You get a mentor in industry. So I have an industry expert who's been in the industry for years and years and years and years. And they help introduce you to people, they help you get on committees. You're meeting with other young people that are just entering the industry as well. You get hands-on experience and you get to learn from your peers. I think it's a great experience.
Would you recommend somebody who's maybe newer in the industry consider joining IPC, or is there not an individual or a path in, I guess, for individuals? Is it only corporate memberships?
There is individual membership as well as the corporate memberships. I think the corporate membership does make it a little bit easier. But individually, I think it's so worth your time. Just sit in on a few committee meetings, hear how the standards are created, and learn from past and future engineers.
The standards committees I've sat on are IEEE and ANSI. I've never sat on an IPC standards committee, and I'll be honest, it's something I have considered getting into recently. But I think the challenge, and this just for me, is knowing which set of standards I should be aiming for to try and participate in. How do you think someone can go and figure that out for themselves? Is it just based on where do they operate in terms of technical expertise, or should you look for a problem that you can help solve and jump into standards participation that way?
Yeah, I think both. Sometimes I sit on committees that I might have an interest in, like design, and I have no experience in, and I'm just a fly on the wall listening. And then there's other committees like the solder mask committee that I co-chair, and I'm helping leading the new standards for solder mask. And so I think a little bit of both. It's what you're experienced in as well as what you might want to learn more about.
So solder mask committee. So this is a good example of the kind of stuff that goes on in standards committees for anyone that's out there that's listening that has never participated in this kind of thing. It seems like it's something that's so minute and like an afterthought. So maybe you can explain what goes on in like a solder mask standards committee meeting.
Oh man, I think each committee kind of has its own personality. It's kind of funny. Each group operates a little bit differently. Solder mask is a little bit of a smaller one, but we talk about flammability ratings and different test methods for testing your solder mask, as well as creating standards for debris in the mask, mask openings, the thickness of the solder mask, things of that nature.
And so one of the sometimes the standards committees that you're on, at least the ones that I've been on, I know that sometimes the minutia can get a little or can become the subject of a heated debate. Is that something that you've experienced dealing with something like the solder mask committee?
Not in solder mask particularly, but I sat in an assembly committee once, and they had an argument on what defines a hole and what defines a void in the solder. For a couple of hours.
For a couple of hours, just the definitions.
Yeah.
That's always fun. Well, I guess in those kinds of situations, you can sit back with your coffee and get some work done in the background while they hash it out.
It's true, but it's also so interesting. People are so passionate about their jobs and what they do that they're arguing about what's a hole and what's a void,
I know. Well, and it seems so I guess it seems so insignificant on the surface, right?
Mm-hmm.
I mean,
yeah,
they should, I mean, and if you just back out, it's like, why aren't they synonymous? But I guess when you really get down to some of the nitty gritty with reliability, then you can really see, oh, this actually does matter, and we have to hash this out.
Agreed. Totally.
Yeah. So now I mentioned at the beginning of the discussion that you work at TTM.
Mm-hmm.
So maybe you can tell us how you got or how you came to work at TTM and what you actually do at TTM.
Yeah, so I was actually pretty interested in TTM from the start of my industry experience. They are the number one circuit board manufacturer in the United States, and I wanted to work for a powerhouse like that. I thought it was great. And then I also wanted to come live in the mountains. So I moved myself from Michigan to Utah, and I work at the Logan division. I'm a process engineer for our solder mask department. It's one of our biggest departments at this facility. I do the day-to-day efficiency, quality, and then working with my operators on their processes and how to improve.
So when you say process engineer, can you break that down a little bit more as far as what's involved in process engineering? Because I think it's an important area of manufacturing. And I think a lot of students who may want to get into manufacturing might find themselves with that job title at some point along their journey.
Yeah, and I think process engineering is a great way to start for most engineers. If you don't know anything about a topic, you're hands-on. I probably spend 40 to 60% of my time on the floor. I know how to run all my equipment. I'm figuring out any quality issues. I'm working with my operators very closely. I am trying to figure out how we can push more panels through every day. That's a big thing about process engineering, is looking at your efficiency. What can you do better? What can you do leaner? How can you make your quality better? How do you prevent problems that you've been having?
So I guess in terms of the engineering problem that you're trying to solve, it's try to maximize throughput while minimizing defect count or maximizing yield, however it is you quantify yield.
Right. And I think most people would think that you'd be working with robots, but it's very human, and humans make mistakes by default, right? And so it's a lot of like, well, how do you prevent that mistake? How do you be smarter than the machines that they're dealing with the people, and preventing their mistakes before they happen?
Well, and you brought up working with robots. One of the things that I think comes up kind of often in the onshoring discussion that has been going on broadly is a big investment in automation, and especially in automation within PCB factories. Is that something that you think changes the role of a process engineer from someone who's just running machines to someone who now has to, command and control a robot essentially?
Yeah, I think it's a different set of problems, right? So people might make mistakes, but machines mess up sometimes too. And they take different levels of controls, and sensors can go out, and wheels can break, and gears can fall off. And you can have all sorts of other issues than you would have with somebody dropping a panel.
And so at that level, it sounds like you actually have to get in and diagnose some of those things and determine, is the line down for maintenance? Do we got to call somebody?
Yeah. And that's some of my favorite parts, is digging into it and finding the issues.
Yeah, definitely. Although I will admit, when I was working in a lab, I preferred not to have to fix everything. But I get what you're saying, right? Because at some point, if something's not working, you got to pull open that piece of equipment and try and find out what's wrong.
Right. And I mean, that's what you have a maintenance team for. But initial investigation, it's very fun.
That's true. Yeah, at a larger facility, or at a larger company, I guess, and probably a larger facility like where you're at, you probably do have a dedicated, maintenance team that comes in and handles all this stuff, ensures uptime, things like that.
Yeah.
So, how long have you been at TTM?
I've only been here a year. So I actually just graduated in December of last year.
So what does the career path look like for someone in your position who's just come in as a process engineer working at a big manufacturer? What does the future look like for someone in your shoes?
Personally, my goal is to learn more processes outside of solder mask in the next few years, and then work my way into operations. That's just what interests me. Anyone at any facility really, or any company, can figure out where they want to navigate, what they want to do.
Well, I guess based on that response, it sounds like there's a lot of room for growth for a young person who's coming in and just getting started in process engineering.
Yeah, and I think a lot of the industry has that growth because they were lacking for so long that middle generation or this younger generation, I feel like the industry alone just has so much opportunity.
I would agree with you. I know that the age distribution is a bit bimodal. So there's a cluster of folks who are much more experienced, and there's a cluster of folks who are much less experienced, and there's not a lot in the middle. Is that actually something you notice working at a larger company?
A little bit here and there. We have like our industry experts, and then we have like our younger generation. But like, again, when you go to Apex and stuff, you see the same thing.
I have particularly noticed the same thing at PCB West, PCB East.
Mm-hmm.
So I get exactly what you're talking about. And there was, of course, recently a report from IPC, and then a survey from PCEA looking at the demographics, and then they identified that as well, with a wave of retirements coming up on the horizon. So, it really sounds like there's a lot of room for growth for young people coming into this industry.
And I think that's one of the most exciting parts, right? Is that you get to become the new subject matter expert in whatever topic you want to learn, because those people are going to be retiring in the next 5-10 years.
Yeah, I totally agree. There was one thing that I think there was one thing that prevented me from going, into manufacturing, at least when I was, your age, which wasn't that long ago, but still, my parents' generation, I guess, kind of saw manufacturing as something that was not really for a younger person. And they kind of expected you to go off and be a lawyer or a doctor and worked in an office. And I continue to be impressed by the technical challenges that folks who work in manufacturing have to deal with. Do you find that you actually, really get pushed to kind of your technical limit at some points in doing your day job?
Yeah, I do. And I think a lot of students in college I found wanted to sit at desktops, and they wanted to be designers and work on software. And they didn't really want to work in a factory where they were making things and dealing with people and solving quality issues. And that's something that I found that I absolutely loved. I'm constantly being pushed on problems. And it's not like when you're in school and you have a problem and it takes you an hour to solve. This is a problem that might last you a day, a week, a month, And so it's constant like problem solving and reinventing your skills and learning how to solve different things.
Well, I guess what I'm getting at is there a perception, or was there a perception, at least for you, that a job in manufacturing was not an engineering job, that it was, tantamount to like manual labor almost?
I think there still is that perception. Yeah. And I guess I probably kind of snuffed up my nose a little bit too until I started working with manufacturing and learning that it's actually harder than it looks on the surface.
So here's what I'm getting at. So the thing for you that actually caused you to connect the dots was actually jumping in to these internships and then getting involved. And I think that was like when the light bulb went off.
Yeah. Yep. Working with those other engineers and seeing that they were very smart and very technically skilled, and that their jobs are harder than I assumed they would be.
So I'm wondering if that's really the key to getting more, students and young people involved in manufacturing, especially in the circuit board industry, because I think there's a lot of young people who have those skills in them to do really well in manufacturing. And maybe they go into semiconductors and then they get burnt out and go somewhere else. And then it's almost like we've lost that talent. So I've been wondering, what can we do to get more young people involved in manufacturing? And it almost seems like, seeing is believing.
Yeah, I think that's a huge part of it. And I think people, especially students, want to be on the front end of technology. And I don't think that they realize that circuit boards are still evolving and our technology is getting more and more advanced as days go on. And once you build that foundation and you learn your processes, then you can start learning how to build substrates and how to build semiconductors and be on that front end.
Yeah, I think there's even still this perception that, the circuit board is really an afterthought. Like, it's not something that's heavily engineered, or it's not something that requires very specific practices to ensure that it works properly. It's just kind of an overblown way to wire chips together, and then it's just kind of ignored.
Yeah, I think the same perception exists, and it's so hard, right? Because they're custom. No board looks the same as another board from another company that you're building for. They all have different materials and different layouts and different layer counts and all kinds of different features. And so they all have their own challenges.
Yeah, I agree. I kind of saw myself when I was younger going into like Intel or another fab, and throwing on the bunny suit, or doing something in metrology, because I used a lot of microscopes when I was doing research, and so I thought that's where I would go. And once I started doing design, like, I really saw the light, and it clicked for me, like, oh, you have to actually very precisely engineer this. You can't just throw it all together and expect it to work.
It takes so much consideration on all steps of the process, right? Design, and then manufacturing, and then assembly. And there's so much thought that has to go into it to even build your smartphone.
Yeah, I think smartphones are really the place where I think the rubber can meet the road for some students. So, I mean, I don't know what universities have to do specifically in terms of like how they structure their programs to get students to maybe pursue this industry a bit more. But I'm wondering if like those kinds of examples are going to be convincing.
I agree. And I think even telling my operators what we build every day and what kind of products they go into, their eyes get all big and they're like, really, that's so cool. And so maybe that's a way to engage students too, is say like, who builds your computers? Who builds your smartphones? Who builds your tablets? And how do you design those? And then how do you fabricate that?
Yeah, that's true. I mean, there's so much focus on the chip, there's so much focus on the semiconductor. And I mean, even with the media, because over the past 18 months, like it seems like the story has just constantly been on the media, chip shortage over and over again. And everything else that goes into the end product, which is arguably many more components than just the chip, all of that just gets lost and no one focuses on it.
It does. I agree.
Yeah, I agree too. Well, thank you so much for joining us. I know we're getting up there on time, but I think as I guess a final thought from you, it would be interesting to see if you could maybe suggest some of the things that you think would engage students a bit more to help them get involved in an organization like IPC.
Yeah, I think at the college level, joining clubs, I know IPC and IEEE have clubs and student chapters at a lot of colleges. So I definitely recommend getting involved with those, reaching out to your local companies in your college town or even your hometown, figuring out if you have manufacturers or assemblers or designers. I think there's a lot more out there than people realize in the US. And then go to those trade shows, sit in on a room, be the fly on the wall. I did it for a few years.
I agree. Go to the trade shows. I have gotten, every time I go, so much information, always learning something new. So it's great to hear that you also advocate for the trade shows.
Yes, I love the trade shows. I love seeing what's coming in equipment to make the circuit boards. I love meeting with old friends and learning tons of stories.
Absolutely. Yeah. And the networking is so valuable.
So important.
Absolutely. Well, Paige, thank you so much for joining us. This has been a great discussion. And as I said earlier, it's always great to meet young people who are involved in the industry and especially who are involved in manufacturing. Thank you very much.
Yeah, thanks for doing what you're doing, Zach.
Oh, I try. Thank you. And to everyone out there that's been listening, we've been talking with Paige Fiet from TTM, also heavily involved in IPC. We're going to have some links in the show notes that you can go and learn more about IPC and some of the initiatives that IPC is involved in with Altium. Make sure to hit subscribe if you're watching on YouTube, hit that like button on the video, and you'll be able to keep up with all of our upcoming episodes and updates. And finally, don't stop learning, stay on track. We'll see you all next time.